Okay, so today we're going to look at looking at simultaneous equations, and that's solving them but using matrices. And to do this, we are going to have to use the inverse, which is what we looked at the other day. So remember, we looked at how we calculate the inverse of a we manually looked at it like a 2 by 2 and things like that, but we know the inverse is like timesing it to the power of -1. And the inverse is essentially like if you times something by the inverse, it's the way we divide in matrices. So we're going to need that for this when we solve simultaneous equations, which is why we did it. So we're looking here, we're going to have a set of simultaneous equations. So for example, so I'm making this up, so we might have like two equations like this. So I might have 2x plus 5y equals 10, and then I might have 3x minus 8y equals, I don't know, 16 or something like that. Okay, so I have those two equations. So what really is the unknowns are these x and y. We don't know what they are. And when we solve them, we're trying to find what they are when those two equations will equal each other. So it means they would be the same thing, and that simultaneously would be the same answer. So you might have done that with other ways in other methods in previous years, but we're going to do it in matrix form. So you can see, first of all, we have the set of equations. So I wrote a few examples there. And what we do, we're going to set it up in matrix form. Now, to set it up in matrix form, what we'll see is in the very first matrix, this will be a square matrix, and it'll have the numbers that are in front of your unknowns. So for that example I've got there, I've got 2 and in front of the x, and I've got a 5, and then in my next equation I've got a 3 and I've got a -8. So that's how you set up your first matrix. And then what you do, then it would be multiplied by your two unknowns. So because I wrote x's first, I put x first on top, and then I put the y. And then you write equals, and it'll equal another matrix which has the answers to your equations. So it would be 10 and 16 here. Okay, so that's setting up those equations. That's what it would look like if I wanted to set it up in matrix form. So, and we can see that if we go over, remember what we did with our multiplication, if I went run and dive, you can see if I went through those matrices doing that, I would end up with the original equation, because it would have been, if you look at it, it would have been 2 times x plus 5 times y. So see, when I multiply those two together, I end up with that expression up here. So you can see how that is a way to express those equations in matrix form. All right, so what we do there, so once it's set up, we want to work out how to solve it via matrices. So what I've done here is I'm calling this first one, I'm just giving it a label. So I called that one matrix A, and I called this one matrix X, and I called this one the E, because it was just the end one. So what we're doing is we're multiplying those two together, and we get the answer here. All right, so that's what we're saying there. So essentially, if you had that scenario in a say in an equation, so say if I had AX equals E, if you were trying to get this X by itself, you would move this A over the equal sign. And because it's multiplying over there, it would divide over here. So remember what I said, we can't divide in matrices, we multiply by the inverse. So to solve it, that's what we're going to do. So you can see down here, to solve what matrix X is, we're going to use the inverse of this first matrix. That's what we're doing, and we're timesing it by the end matrix. So what we're going to do is, if in my little example, it would be that first one to the power of -1 times that end one, which was 10 and 16. Okay? So that's how we solve it. Now, be careful, because remember, order is very important when you're multiplying matrices. Now, because the one that we are moving, see A is at the front here, we're going to make sure that the inverse is at the front on the other side. If the one we knew was after the one we don't know, and you'll see it later, you'd use the inverse after it, and I'll show you that later on. So anyway, so that's how you would solve it, and you'll end up with a matrix. Obviously, you end up with this 2 by 1 matrix, and that essentially this answer will tell you what x is equal, and this one would tell you what y is equal to. So here when I've written how to solve it, you can see that formula just in there is the inverse. Yeah, that's how we found the inverse the other day. So I've just expanded that out. You don't have to worry too much, because obviously you can just use the power of -1 on your calculator. But if they asked you, you know, like a problem solving question where they're stepping it out a bit more, if they said, you know, find the inverse matrix that you're going to use to solve this, you might have to do the whole process. But just read the questions. So for a set of, when you've got 2 equations, that's what it's going to look like. And we're just going to have a look at if we have 3. I'll just pause it. Okay, so here we're asked to solve this using matrix form. So I want you to be really careful with the method or what they're asking you as well. So first of all, I'm going to show you, we're going to put this set of equations in matrix form. So first we're going to write the equations out in matrix form. So that's when we are going to put the numbers in front of the x and y first. So I've got a 3, a 4, a 2 and a 3. And then we multiply it by the unknowns, which is x and y, and then I let the answer be the 6 and 4. Okay, that's just in matrix form. Now, to solve it, to solve using matrices, because we know you can use this other solve function on your calculator, but they want you to solve using matrices. So to solve using matrices, what we're going to do, we'll write this out. We'll write x, y equals, now it's going to be the inverse of that first one, so -1 times this 6 and the 4. Okay, so what you can do is, you can just type this straight out in your calculator, but what I'm going to do, and you don't have to do this every time, but I'm going to step it out, and first of all, I'm going to find the inverse by itself, and then I'm going to times it, all right? Just because sometimes they make you do it step by step. And if they do that, I want you to be able to see it. So let's do this on our... Okay, so we did this, and that's what... So this one in the green was the inverse. So I calculated that, and then I ended up with 2 and 0. So what I'm saying is that when I've solved those equations, and you should then write an extra separate statement. So we should therefore say x equals 2 and y equals 0. So they match up across the rows. Okay, so you can see, because it was this matrix here, this was the matrix that we used, we found the inverse. So remember, the inverse uses the determinant. And remember, so you need to remember when the determinant equals 0, so because the determinant in this case, this one's determinant would have been 3 times 3 minus 4 times 2, so it would have been 1. So because the determinant was not 0, we found the inverse, and therefore our unique solution. So when they talk about that unique solution, this is the unique solution. So if you can solve them simultaneously and you do get an answer, that means you have a unique solution. So that means the determinant must have been a number other than 0. So sometimes if you don't want to work it all out, if they just ask you, do these equations have a set of, does it have a unique solution? Well, if you want to check if it has a unique solution, you can just, so if you want to check for a unique solution, so you don't want to know what it is, you just want to know that there's an answer. To check for a unique solution, you just make sure the determinant, the det, doesn't equal 0. And that's the determinant of this first matrix. Okay, so it can save you a bit of time. You don't have to do all the whole process. So for the next one, we can have more than one unknown. And so if we have 3 unknowns, so before it was x and y, now we've got x, y, and z. So if you've got 3 unknowns, you're going to have 3 equations. So you still set it up the same in terms of all the numbers in front of those letters will go in a matrix at the start, and all the what those equations equal will be the matrix at the end. Okay, so just to show you, we've got an example here. So let's go and set it up. So there's 3 equations there, and they're saying solve using matrix form. So I'm just going to show you this first. If we want to do the setup, I'm going to do a 3 by 3 because I've got 3 matrices. So I'm going to see all the numbers in front of x, y, and z. So I've got, for the first equation, 3, 4, and -2. In the next equation, I've got x is 2, y is 3. Now there's no z, so when there's no letter there, you put a 0. So there was no z in that equation. And in the last equation, x is 1, the y is 2, and z is 3. So there's the number 1, and then you put your unknowns in the next matrix, and then we would say it equals the answers to that, those equations like that. So that's set up. Okay, so that's set up, and then we're going to go and solve. So to solve it, what I would do, so this is solving, I'm going to put that first matrix into the calculator. Now, we don't know how to manually find the inverse of anything bigger than a 2 by 2, so obviously this one would definitely be putting into the calculator. So we just do the inverse times that ending matrix, and we'll get our answer. So you're just typing this bit into the calculator, and we're going to get our answer. Okay, so I typed that in, and I got -11, 7, and 0. So therefore you say x equals -11, y equals 7, and z equaled 0. Okay, so here is just summarizing it up for us. So to set it up, this is set up. So if they ask you to express the equations in matrix form, that's what you have to do. And then if they ask you to show what you did for solving, then you would do, this is showing the solving. Yeah? So you'd be more showing that part of it. So often they get you to set it up first. So if you look at this next question here, it says the solution of the matrix equation here. So really, it was a set of simultaneous equations. They've already worked it out, yeah? And you would have to solve it. So we know if we move this matrix over, it's multiplying on the left. We sort of want to divide on the other side, so we would use the inverse. So we pop that in the calculator, and we can see this is how we get answer B. Just another example, and they show you how you do it on the calculator if you're storing the matrices. So there's that. But once again, they're just reminding you down here that if you solve it, you get that unique solution. So really, the summary about the unique solution, so if you see the unique solution, what that means is the determinant did not equal 0, okay? And remember that that's the other combination, or the other way they'll say which matrix is singular, and singular matrix, remember you might just wrote a singular matrix was when the determinant did equal 0. So did equal 0, okay? They're really the only wording you need to know. Okay, with this table, what I'm trying to show you is you might not get it written out like this, but what you're going to have is, what I'm saying here is this X matrix is going to be the one that you don't know what it is. So in your problem solving, so it could be written out in a scenario, but X is the matrix you need to find. Is the unknown, is the matrix unknown? And the question, really. So what you're trying to find out. So what I'm writing in this table, if you get a scenario, so they may say, right, we give you A, and we know that A plus X equals B. So you know what this is, and you know what that is. You've got a matrix and it's got numbers in it, and you need to find X. So it's pretty self-explanatory for this one. If you're trying to find X, you would just go B and you would subtract A, okay? So that's pretty much basic thing. And then the next one, obviously, if you had X minus A, so what I'm saying is X is the one that you don't know, you would find it by adding B. All right, so with the next one here, so if I said, I'll do a little example for this one. So if, say for example, you knew that 2 times matrix X, so you don't know what matrix X was, but you knew it equaled something like this, okay? So what I'm saying is, the way you would solve that is that you would say, all right, you're going to do a half times that matrix, and that would have told you what matrix X is, okay? So you end up going, and I'm just doing easy numbers so that you could see. That's pretty easy to understand, yeah? So if you times that matrix by 2, you'd get that answer at the top. So that's what I'm trying to say. So this is how you would calculate that working out. So if you, so the red X is always the unknown. So down here, this is the simultaneous equation scenario. So what we do know this one. This is the one that has all the numbers in front of our X and Y's, and this one is the end one. So you knew this is how we solved it. We solved it by using the inverse at the front. So just what I wanted to take note of, if you get given a scenario, now it would not be a simultaneous equation scenario, it would just be another situation where they may say, here is, we don't know what matrix X is, but if you multiplied it by A, you would get the answer of B. So then when they say, well, find X, so what you would do is you've got to move that A over an equal sign. You want to divide. But can you see, because it was after the one we didn't know, you have to multiply the inverse after the other one. Can you see the difference there? That's what I want you to be careful of, because this would be a challenging question. This would be something that you can do. You do know the theory, but it would really be testing your knowledge on whether post-multiply or pre-multiply. So we've got it there, so just to be careful. When the determinant does equal 0 and you can't solve, you can't solve the simultaneous equations, these are the two things that are happening. It's either the lines are parallel, so they never cross to get that unique solution, or the two equations are actually the same line, but it's just written differently. So you don't need to stress too much about this, but just so you've got a bit of an understanding what's going on. But as I said, if all they're going to ask is like this question down here, they said, how many of these simultaneous equations have a unique solution? So we didn't bother solving it. We just found that first matrix and then found the determinant of them. And you could see only the first two had one that was not 0 and the last one did. So these would have a unique solution. Okay, these two here would have a unique solution, and this one doesn't. So this one, because it's 0, this one's a singular matrix. And that's pretty much all you need to know. All right, so state whether there is a unique solution for this equation. So you could have just quickly worked out that the front matrix would have looked like this, and then we could have worked out the determinant would have been 2 times -6 minus 4 times 3. So that'd be -12 minus 12, so it equals 24. So yes, it would have a unique solution because the determinant isn't 0. Okay, so down here it says, question 3, the matrix equation below represents a pair of simultaneous equations. These simultaneous equations have no unique solution when m is equal to. So you know no unique solution means the determinant has to equal 0. Okay? So therefore, you could go and look at that matrix at the front, this one here, and we're going to work out its determinant. Its determinant would have been 12 times 3 minus 9 times m. Now, you know that has to equal 0. So now you've got an equation, and you can just solve. If you're not good at algebra, that's okay. Just solve it, comma, m. And what's that going to be? 4? So m equals 4. Okay, the system of 3 simultaneous equations above can be written in matrix form. Now, so you have, if you look here, you've got 3 equations. So you must have a 3 by 3 to start with. So if we were setting these up, the setup, x, y, and z, it would be, now there's no x in that one. It's 1 and -1. There's 5 here, -1 and 0, 1, 0, and 1. And then it would have been times x, y, z, and it would have equaled 8, 0, and 4. All right, to solve it, but they said which can be written in matrix form. So you're looking for that. Now, where's that answer? So that's B. They didn't ask you to solve it, they just wanted it in setup form, so there it is. Okay, the matrix equation below represents a system of simultaneous linear equations. One of these equations could be, so here's where they're wanting you to go backwards. So really, remember like I said before, when I explained how this sets it up, you would actually go run dive, and then it would equal that. So if I wrote out the first one, it would be 2x plus 1y, and there's no z's, so plus z equals 3. If I did the next one, so if I went run, dive, equals that. So the next one is -3y plus z equals 2. So remember, this has got to be x, y, z along there. And then the last one would be -1x plus 2z equals -6. So is there any of those equations in B? Yeah, so there's one of them. Okay, 4 matrix equations below each represent a set of simultaneous equations. The number of these simultaneous which have a unique solution. So all again, just write unique solution, determinant does not equal 0. So you could just work out the determinant of them all. So the determinant of this guy here would have been 2 times -1 minus 1 times -2. So that would have been -2 plus 2. So that one's 0. So it has no unique solution. So no unique solution. This one's determinant would have been 6 times 1 minus 3 times 2, which would have been 0. So none for that one. The one underneath, the determinant would have equaled 3 times 4 minus 6 times 2. That would have been 0. None for that one. And this one would have been 1 times 1 minus 1 times 1. So how many have a unique solution? 0. A worker can assemble 10 bookcases and 4 desks in 360 minutes and 8 bookcases and 3 desks in 280 minutes. Each bookcase takes B minutes to assemble and each desk takes D minutes to assemble, and the matrix BD is given. So what you often get is these simultaneous equations but written in words. So if you have a look, I could say 10B plus 4 desks equals 360, and then they say 8B plus 3 desks equals 280. So there I've got my 2 simultaneous equations, and they said how do you solve it? So they actually want the solving of it. So I'll write them out underneath each other like you're used to. So if it was written like this, and then if I was to write in the setup, I'd have 10, 4, 8 and 3 multiplied by B and D, and it would equal 360, 280. Okay? Now they want me to solve it. They want to show what it is to solve it. So that means I would have to put the inverse in and times it by this one. Okay, so they here, if you have a look, they have not got anything to the power of -1. So that means I have to work out what this inverse actually is. We need to get that because that's not how they've written the answer like that. So let's go have a look. Okay, so I've typed that in the calculator. The inverse actually looks like this. Alright, so do I see that answer written somewhere? I do, in A. So how I got this matrix here was I actually typed this in the calc. Alright, question 3. A basketball coach has written 3 linear equations to predict points, rebounds and assists in Oscar's next game. And there they are. Now it says fill in the missing information to make it matrix form. So all you have to do is go put the numbers in front. So this is pretty easy. So there it is. The matrix equation is solved using the following. So determine the value of x. So what they've done here is this, you've got to find the inverse of this one up here and just fill in the missing dot. So I've popped that into the inverse in, and I found that x equaled -5. And then it says how many rebounds will Oscar predict. So you pretty much just have to solve it and times that. So now that you know that, you actually just solve this out, and when you solve that you get 19, 10 and 4, but it says how many rebounds, so you just want, sorry that's 10, you just want the rebound answer, so you just say 10. So I did this, this multiplication and we get the answer. So this would be points, rebounds and assists, and they only wanted the rebound answer. Okay, this one, you just got to find the equations again. So I'm just going to go through it. It would be 2v plus 2w minus 2y equals 2. And then the next one would be 2v minus 2x equals 6. And my next equation would be 2w minus 2y equals negative 8. And then the last one would be 2v plus 2w minus 2x equals 4. So you're looking for that combination, and which one was that? Yeah, and we get B. So I was just doing the run and dive, yeah? Run, dive, got that answer. Okay, Liam runs, swims and walks for several exercises for several times a month. So each cycle kilometre he does is given by a C and blah, 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 and the R and for what he runs and that, things like that. Okay, the total number of times Liam cycled, ran and swam and walked each month over the 4-month period, and the total distance that Liam travelled in each of those months is shown below. So the matrix that contains the distance each time he cycled. So it was really like simultaneous equations. So what this would be, if it was written out, you'd say, okay, 5C plus 7R plus 6 swim plus 8W equals 160. So that's what you have an equation for 4. Because there's 4 unknowns, there's going to be 4 equations. So they just want you to solve it. So really what you would be doing, this is like the matrix that's written out at the start, yeah? Because they've got cycle, run, swim, walk, and here's cycle, run, swim, walk. It's the same pattern. So what I'm going to do is I'm going to type those numbers in as a matrix, and I would raise that to the power of -1 because it would be the inverse. Sorry, writing this out. So that would be like a thing. I'd go to the power of -1 times what the equations would equal, which was this, 160, 172, 165, 162. So we'd type that in our calculator, and that would give us our answers for cycle, run, swim, and W. So, okay, so we get 8, 6, 1, and 9, so it's B.